Okay, so we are starting volume. So for the past 2 weeks or so, we've been doing surface area, which is the area of all of the faces of whatever 3D figure that you're talking about. Today we're starting volume. Now volume is actually like how much something will hold. So if you poured water into this little rectangular prism right here, I want to know how much that rectangular prism will hold. Okay. So volume, I think that y'all will like a lot better than surface area. The formulas are way simpler. Um, so I don't think that you'll have as much trouble with it as you did surface area. Okay, so we're going to start with I'm going to say this too. With surface area, just like surface area, there's a different formula depending on what kind of 3D figure that you're talking about. So if you're trying to find the volume of a rectangular prism, you're going to use a different formula than if you're trying to find the volume of a cylinder. Okay, so we're going to do rectangular prisms, and then we're going to do a few triangular prisms, and then we're going to do cylinders. Okay, all right. So we're going to start with rectangular prisms. Remember, rectangular prisms look like a box. Okay, it can be a cube or it can just be, like a longer, skinnier box, but it's going to look like a box. The formula that you're going to use for a rectangular prism is going to be length times width times height. And I am putting a big box around that formula right here. Length times width times height for volume. Just like with surface area, it doesn't matter what you label as the length, what you label as the width, what you label as the height. Don't get all fixated on that. Just pick a number and go with it. So I'm just going to do length, width, height. Okay, so now I'm ready to plug it into my formula. Volume equals length times width times height. My length is 9. My width is 17. My height is 24. If I type in the calculator, 9 times 17 times 24, I'll get 3,672. Okay, so with surface area or any kind of area, we would put centimeters squared right here. Since it's a volume, you always say your units cubed. So this will be centimeters cubed. Okay, let's do one more rectangular prism and then we'll move on to triangular prisms. Okay, so number 3 asked me to find the volume. This is a rectangular prism. It looks just like a box. So I need to label my length, my width, and my height. I'm just going to make this my length, that my width, and that my height. And then I plug it into the formula. Volume equals length times width times height. My length is 39. My width is 12. And my height is 8. If I type in my calculator 39 times 12 times 8, I'll get 3,070 or 3,744 feet cubed. Since it's volume, I say feet cubed. Okay, so that should be pretty good for you guys. Let's move down to triangular prisms. The formula for volume of a triangular prism is going to be that capital B times the height. Capital B times the height. Now, we know from doing surface area that the capital B is going to be the area of your base. Okay. This is where I think some of you might be kind of messing up. So, it doesn't matter how the triangular prism is sitting on what you think is like the floor or the surface. You always use the triangles as your basis. Okay? So, like, let's look at 5 and 4 at the same time. So, if I look at number 4, it does actually look like it's sitting on the triangle part. So I have this triangle that I'm highlighting, and that actually does look like the base. And then I have this triangle on top, which is like the top of the figure. Okay? That purple triangle that I just highlighted is going to be your base. Okay? And it looks like it's actually sitting on that bottom triangle. Look at number 5. Number 5, it looks like it's sitting with this rectangle on the bottom. But you don't call that rectangle your base. Your base is still going to be your triangles. So This front triangle can be one of your bases. And then this back triangle could be one of your bases. Those are your bases. Okay? It doesn't matter how the figure is sitting on the surface. If you're working with a triangular prism, you choose one of your triangles to be your base. Okay? All right, so let's go ahead. I'm going to erase that so I can start. I just wanted to explain that before we got going. Okay, so if my formula has me having the area of one of my bases, then I've got to find the area of my base. So we already talked about the base is going to be your triangle. So I'm going to use this pink triangle that I've highlighted here. So the area of a triangle is 1/2 times base times height. If this right here is 12, that means that this base of this bottom is going to be 12. So the base of my base is actually 12. The height is going to be from the bottom to the top point right here, which is going to be this 7.3. Okay, so if I do 1/2 times 12 times 7.3, the area is going to be 43.8. So that's what I'm actually going to use as my capital B. Okay, so let's look at my formula. Volume equals capital B times the height. The height is going to be the distance between your two triangles, between your two bases. So if I have this base down here, and then I have this base up here, the distance between those two bases is this 5. So that's going to be the height that I plug into H. Okay, so let's plug in our numbers. So for capital B, it's 43.8. And my height is going to be this 5. So then if I multiply 43.8 times 5, I get 219 feet cubed because we're talking about volume. Okay, I'm going to do number 5, and then we're going to move on to cylinders. Okay, so this is a triangular prism. My formula for volume of a triangular prism is capital B times H. I know that capital B means area of the base. We talked about that the base is always going to be the triangle if you're talking about triangular prism. So I'm going to look at this triangle right here to find the area. Area of a triangle is 1/2 times base times height. I'm going to bring down my 1/2. The base of this triangle is 11. And the height of this triangle from the bottom to the top tip point is going to be 5.4. If you type in your calculator, 0.5 times 11 times 5.4, you get 29.7. So that means that my capital B is going to be 29.7. Okay, my height, remember, is the distance between the two bases, between the two triangles. So if this is one of my triangles on the front right here, and then this is one of my triangles on the back, the distance between those two triangles is this measure right here, this 16. So that's what I'm going to plug in for my H. Okay, so now I just substitute and multiply. My capital B is 29.7. My H I determined is going to be 16. And then if I multiply 29.7 times 16, I get 475.2 millimeters cubed. Remember, I always have to put cubed because I'm talking about volume. Okay, let's go to the back and let's do 2 problems of cylinders. Cylinders are super easy. Okay, so depending on what 3D figure you're talking about, your formula will change. So for a cylinder, your formula is going to be pi times r squared times h. R is going to be my radius, just like always. Height is going to be your height between the two bases. Bases in this case are going to be our circles. So if this is a circle, and then this is one of my circles, the height is going to be the distance between those two circles. Okay, so let's do number 9. This is a cylinder. It's asking for volume. So I use the formula. Volume equals pi times r squared times h. Okay? You can use the pi button on your calculator, or you can use 3.14. I'm going to use the pi button just because it's a little bit easier, but you can use 3.14. Okay? So I'm going to bring down my pi because I'm using the pi button. My radius, it gives me my radius already in the diagram because it goes from edge to center. So my radius is going to be 18. So I'm going to substitute 18 squared. And my height is this right here, which is 15. So if I type in my calculator, pi times 18 squared times 15, hold on. I get 7,000. Oh, wait, no, I don't. I get 15,268.14 inches cubed. Okay, I'm going to do one more. Number 10, it is a cylinder. So I'm going to use the formula for volume of a cylinder, which is volume equals pi times r squared times h. Okay, I'm going to bring down my pi because I'm just going to use the pi button on my calculator. Now I need the radius. They gave me the diameter because they went from this edge to the circle to this edge of the circle. I only want from edge to center. I only want this part. So I'm going to take their 11 and I'm going to half it. I'm going to divide it by 2. If you divide 11 by 2, you get 5.5. So my radius is actually going to be 5.5. So where it says r squared, I'm going to substitute in 5.5 squared. Okay? Now I'm worried about my height. Now this cylinder is kind of laid over on its side, but we talked about earlier, we want the distance from circle, here's a circle, to the other circle. So the height of this is going to be 21 because I go from circle to circle. Okay? So where it says H, I'm going to substitute in 21. Now if I type in my calculator, pi times 5.5 squared times 21, I'll get 1,995.7 meters cubed. Okay, let me know if you guys need help. See you later.